welcome to this presentation about Kubernetes Native Continuous Deployment, made with Flux, Flagger, Linkerd, and additional tools. My name is Leonid, I'm the Chief Technology Officer at StackPulse. With me is Or, our Site Reliability Engineering Lead, and in this presentation, we will tell you all about our continuous deployment system. So we'll start by explaining why do we even need it and how important it is. Then we will talk from the high-level perspective, that will be my part in this conversation, about how it works. And then we will zoom in on each and every component in the system and ask questions, hopefully difficult ones, about why certain architectural choices were made, what is the exact function of each and every component, what are the alternatives that we considered and decided not to choose. That's it. Hopefully, in the end of this talk, we will leave you with a lot of lessons learned and food for thought on how to build your own continuous deployment for Kubernetes-based applications. So, first and foremost, we are a fast-growing enterprise-grade software as a service solution. As a result, when penetrating the market, since we are a young company, being able to deliver new functionality fast and in a reliable manner is not just a technical consideration for us, it is a business-critical capability. Furthermore, since we are delivering, as I already mentioned, an enterprise-grade SaaS, our customers rely on us to be there for them. We are an automation and orchestration platform, which means our customers rely on an ability to execute their automated workflows every time where they need it. These workflows may be mission critical for their environments, and we should be there for them wherever and whenever they need them. As a service, of course, and as an organization, we are SOC 2 compliant, HIPAA compliant, ISO 27001 compliant, which means that we should be extremely aware of what goes on into our production. We have extensive prior experience in building software as a service solutions, and every time we did pretty good based to our own scores on continuous integration. We do a lot of automated testing, we do a lot of gating, but this is actually the first time where we're taking it all the way to continuous deployments, because we are so aware of the costs that the organization had to pay when stopping just at the continuous integration. So for us, historically, continuous deployment was pretty much the first thing we introduced to our architecture way before we developed large chunks of business logic. Our stack is pretty straightforward. We are a Kubernetes microservices-based operations. We use GitHub as our source versioning. We run a pretty standard multi-repo approach on top of GitHub. Therefore, you could pretty much imagine how the development lifecycle is. From this point on, of course, we are moving on to explain how the continuous delivery works. The strategy that we chose is a canary deployment, which means that every time a new business logic in one of our services is being delivered to production, we progressively shift parts of the user activity, traffic for us, to these new versions, while continuously monitoring how they're doing, and only when we're satisfied with the results will we promote the newly deployed functionality to become as a primary service handling the traffic of all our customers' activities. Such processes can happen, by the way, in parallel for multiple services, and for us, being continuous means that during the day, our system, even in less busy days, is probably handling tens of such deployments, which of course could grow as the company grows and the team grows. So how does it work? Of course, it all begins with a developer delivering certain business logic or configuration changes into a main branch of one of the service repositories. That delivery triggers a continuous integration pipeline. We happen to use circleCI for our continuous integration pipelines. That includes tests on various levels, building container images, and deploying them into Artifactory. So we use particularly Google Container Registry as our store for our main artifacts, the ones that we will focus on which are, of course, container images. This is at the end of this continuous integration pipeline where the artifacts are updated as a result of a successful build. This is where the continuous deployment process actually begins. So we push the artifacts, and then this process triggers Flux continuous deployment that listens, for lack of a better technical term, to these updates both in the releases on GitHub service repos as well as in the image repository, and that's what triggers the process. Of course, at the beginning of the process, we synchronize with the latest changes in all the configuration files as well as the binaries, and when conditions are sufficient to begin the actual deployment, we initiate it by updating the canary deployment that constantly exists in our Kubernetes clusters. We update it with the relevant version of the container image that we are about to deploy, and we start increasing the amount of canary pods, right? The actual containers that will be handling traffic that belong to this new version that we are deploying to production. From this point on, the control over the process moves from the GitOps operator, Flux, whose main purpose is to initiate it, into progressive deployment operator, Flagger. So the main duty of Flagger, and we will talk about it much more, is to gradually start shifting the traffic towards new versions of the components while continuously validating that they are functioning according to our expectations. So at first, like we said, the amount of pods will be adjusted and a traffic split configuration will be defined to start sending, let's say, first 10% of the traffic. By the way, at this point, or maybe even prior to this point, we trigger execution of end-to-end test sequences on this component in production to make sure that we even pass the gate that prepares us to this thing. But still, let's say that 10% of all production traffic of all users is already flowing through these new versions. We would define a period of time, all that of course is configurable, and we would scrape health metrics from our pods using Prometheus to make a decision whether these canary pods are functioning sufficiently well and are now candidates to be increased in the amount of production traffic they're handling. Let's say that this was indeed the case. We update traffic split again. We promote it either by 5% or by 10%. That, of course, is again configurable, both the time interval and the actual jump. And again, query various metrics to make sure that they are functioning according to expectations. If at any point during the process, the results of the query make us believe that the components are not functioning according to our expectations, we will immediately trigger the canary rollback. In essence, the canary rollback is just shifting the traffic back to existing untouched primary service pods, decreasing the amount of replicas on the canary deployment to 0, and of course notifying the relevant parties about the logical failure of a canary. But if the process continues successfully, and we again increase the amount of traffic going through canary pods even more, and then even more, all the way till the point where we are confident in their functioning so that we can shift it to 100%. What happens then is the logical promotion process of newly deployed functionality to become the primary, and it works this way. So what happens is that we first take the resource definitions of our canary deployment that of course contain all the configuration changes as well as the container image version with all the business logic changes, and we override the primary deployment for that particular service. This, in essence, triggers a very Kubernetes native upgrade process where a new replica set is created with the container image and the configurations belonging to the new version. New pods are created in this replica set, and the moment their health and liveliness probe reports positive health and liveliness, every time a pod from the previous replica set is being gradually terminated and replaced with the new pod. This way, at the end of this Kubernetes native process, we reach a state where there is a primary service deployment with exactly the same settings as our original Canary one and with a fully populated replica set, at which point we decrease the amount of Canary pods again to 0. We shift, of course, all the traffic on the traffic split level. We already did this to primary pods, and that actually constitutes a successful completion of our Canary process. So as you can see, it is designed to be very native for the Kubernetes environment. To dive in a bit more, during various stages of our progressive deployment, we use the capability that Flagger has, and we call out external webhooks to our own service. We call it Puerta because it does certain gates. And in this service, we enrich the progressive deployment with additional functionality. For example, in a pre-rollout webhook, which means before we start shifting the production traffic, we trigger our end-to-end tests, right, that cover a lot of user scenarios synthetically in order to increase our confidence in the fact that we can promote this thing, because most important, hopefully within time, all user flows have been tested. We do more than just Prometheus query, and we check success rates and various latency metrics as a part of every rollout promotion. On post-rollout, for instance, inside our staging environments, we go back to our GitHub repos and mark the release only after a successful Canary promotion in production. So we can enrich this process, and we actually do that quite a lot. Last, but definitely not least in the list of tools or processes that in our view are very imperative to succeed in continuous deployment, is our ability to roll out new functionality or functionality changes under a feature flag. So what it is in essence is that on the development R&D level, we surround changes in business logic with a request sent to an external system. In our case, it's an open source project called Flipt or Flipt. And we provide it with a lot of details on the session, and of course, which flag, which decision we are looking for a resolution on. And that system, based on a rule-based, high-level configurable policy, returns a verdict for this particular set of flag and session data, whether the functionality should be enabled or not, relinquishing the control over what users will experience, right, from the engineering floor to maybe reliability engineers, and actually even all the way to our product managers. Just to remind you, before starting to drill down, here are our star actors in this movie. So on the CI side, of course, we have GitHub as our source version and configuration version repository, our single source of truth. And as I already mentioned, CircleCI as our continuous integration infrastructure. Today we will not be touching these a lot. Then of course comes the stage, the very stage we are focusing on, and here of course the GitOps operator Flux that we already mentioned and we'll talk more about, the progressive deployment operator Flagger, Linkerd, our service mesh that plays a very important role in our ability to do this traffic shift and gain confidence that indeed Canary components are functioning. And in a post-rollout world, our control over functionality enablement for different product sessions using this flag flipping that is also known under a different name as dark launching. So for the next piece of our conversation, I'm joined by Or, as promised, don't say I don't deliver, and we'll drill down into these components, starting with CD. I don't think there's much interest to dive into CI. Yeah. Hopefully, we'll make his life difficult with really intensive questions. So, let's start with Flux. So, or as I mentioned, our way of working with Flux is that it works as a kind of reconciliation loop, right? Exactly. It waits for releases to be updated on GitHub and for new images to be pushed to our Artifactory, and then it acts. Tell me, why is this important? I mean, so many people that I've spoken with, they actually initiate their continuous deployment as a last step in a successful continuous integration. So why is it important to do this reconciliation loop?
Yeah, so Flux acts as a component. You are right, it's a reconciliation loop for Kubernetes, and it behaves the same way as Kubernetes does. It accepts declarative data and reconciles it until what you've requested is achieved on the cluster.
So like brings the production state to what we want it to be. Okay.
Yeah. So the thing with Flux is that it helps with lots of different scenarios. It helps here in the CD pipeline, but Flux also monitors Git repos for Kubernetes configurations.
Yes, sir.
It helps SREs and cluster administrators in order to achieve state that comes from Git and that is multi-cluster, multi-region, and you can span out multiple clusters that behaves the same.
All
with
right.
Only simple similarities between annotations and stuff. If it's multi-region and you want to have different behavior in a specific manner in only one configuration, you can achieve that. The thing with this component is that it uses pull and not push.
Yes.
So the permission is given only to the component via the cluster. So the administrator that have the permission to manage that specific namespace, that specific cluster, can do that in Flux only and not give up the permissions and cluster administration to a CI product that acts on an external part of the network.
It's definitely not a part of my production. That's,
and the thing with ownership and microservices is that developer teams are autonomous and they can manage their own CI pipelines and and you want them to be able to do that and create different artifacts and stuff. But you want to control what goes into production and you want to separate those steps.
Understood.
Yeah.
So to sum this thing up to make sure that I understand, it is allowing me a separation and an encapsulation of my CD pipeline, meaning CI's job is to deliver artifacts and it kind of stops there, whereas CD takes these artifacts first. Second of all is the point where we don't deliver to the CI infrastructure any credentials, any network access, anything that will allow it to pierce the security permissions of the production environment and initiate processes there. It's the pool thing. And this thing with autonomous, I have a question. So this means that inside each and every production environment, Flux itself should be treated as a production grade component, because if for some reason it is down, it is not pooling these changes, it means that my CD pipeline will not be launched. How do we monitor that? How do you, for instance, know that right now our CD pipeline is functional and the next deliveries made by the engineering will actually get rolled out to production?
Yeah, that's a great question. So Flux comes with Prometheus metrics built in, and you can monitor the app metric, and you can configure some webhooks that Flux emits on failed apply to the cluster and failed
attempts.
Failed attempts of updating images and pulling from Git and maybe pushing to Git.
And similarly, if the metrics are not arriving, I can alert in my monitoring system on the fact that nothing is. Okay, that makes sense. One maybe smaller question in relation to the previous ones. So I know that different organizations deploy things in Kubernetes in different ways. We, for instance, we use YAML directly defining resources, and when needed, we template it using the customized tools. I know that many organizations are using Helm charts as their main mechanism for deployment. Does Flux care about how it actually initiates the deployment, or is it agnostic?
So there is a way to achieve agnostic way of deploying. You can create your own scripts and stuff, but Flux comes with built-in support for Customize and Helm.
Got it.
So it can parse the Helm charts and actually build the template from the Go template, and then build the output configuration and
Right.
apply that
Specific
to
for the
cluster.
environment.
Yeah.
Absolutely. So native support both for Customize, if you are a fan of writing explicit YAML resources.
Patching and not templating and writing. If
Actually,
you
you're right.
If you want to write native YAML code and node code data instead of code.
Configuration, that would be.
That would be the thing with Customize is that it takes the beauty of declarative language, configuration language of Kubernetes, and says we don't write code in order to generate the output YAML. We just write proper YAML, and
Right.
we can use either the base or the patch as a standalone and extend it.
So you may choose your own philosophy of
Yeah.
deploying, whether you happen to agree with OR that does this thing with declarative YAML, or you would like to use Helm charts. It all is very much native. Okay, let's move to the actual progressive delivery stage.
I just wanna mention two more advantages.
Very important.
Flux that is not related to the CD pipeline and developers.
Okay.
I really like it as an SRE that I can use it as a DRP mechanism. I have everything in Git, and I can set up a new cluster, and it will behave exactly the same as the previous cluster. And the mean time to recover from this is basically 0, since you have the entire configuration and the images are stored somewhere else, and hopefully you back them up too. And
Of course we do that. What do you mean?
Yeah. So I think that's a great advantage of one component that is in your cluster and acts as different roles for different people in the company. And one more thing I want to mention about Flux is multi-tenancy.
Oh,
Okay.
all right. What does that mean?
It means, like we said about the CI pipelines and the ownership, developers want to manage, if you have a few dev teams that are separate and have their own namespace and quota and limits and everything configured by the organizational SRE team, you can have your namespace, and in that namespace manage everything and have Flux installed into that namespace and manage that namespace from a different repo. And the SRE has the cluster-wide Flux, and
All right.
per team you have the advantage of managing your own resources from your own Git repo and deployments and your policy, and you get the best of both worlds.
So it's very important.
Yeah.
The fact that within different namespaces of even the same cluster, I could run very different strategies
Yeah.
in terms of continuous deployment and GitOps thanks to different instances of Flux.
Exactly.
That's a very important comment. Okay, progressive delivery. So this is the component that takes the center stage after Flux completes its job. And in here, we are talking about implementing a strategy for rolling something out. In our case, we will be focusing on Canary because this is what we are doing. So first, very important question. Does it make sense ever to use Flagger without Flux, or is this tool good only when you use Flux as your GitOps operator? Is there such a thing?
Yeah, so Flux and Flagger was built by the same team.
Yep.
And you can see it's a complementary solution, but the thing is, it behaves as the Unix philosophy says, do one thing well, and actually Flagger just triggers a new canary based on a new deployment change. So you can just run kubectl edit and
Flagger will trigger
Flagger
a
will
job.
trigger a job.
All
And
right.
you can use if you already have a deployment mechanism and you actually edit and apply deployments from CI like you are used to, you don't have to use Flux in order to use Flagger.
Very important.
Yeah, so they are a complementary components, but they can work as a standalone, and one can live without the other. So Flagger only triggers a new canary based on changes to the main, the Apex deployment, stateful set, etc.
So as I already told our viewers, one of the most important pieces in a canary deployment is this ability to establish, did this new canary pod or these new canary pods actually manage to handle the traffic correctly? And of course, we do that via Prometheus by scraping various metrics. Now, or these are not just your typical liveliness and health metrics, right? We are looking deeper. Could you please tell those of our viewers who don't necessarily have a very advanced metrics in their application pods, what is like the bare minimum? What kind of metrics would you be looking for in order to make this confident promotion in progressive deployment? What do you need?
So in order to use Flagger, you need another component that is either leveraging an SMI spec, service mesh interface, or more robust service mesh solutions like Istio and Linkerd.
Absolutely.
And these components are aware of application metrics and instrument the application automatically, so you don't have. So you get success rate and latency out of the box with.
So I don't need to do anything. I have my regular microservice, either REST or gRPC, and these things will actually give Flagger the ability to figure out whether the success rate with this new version is significantly. Oh, that's great. Are indeed success rate, by the way, and latency the things you are looking for?
So these are the built-in metrics you get in Flagger. You can use custom metrics. For example, we use Google PubSub, and we can fail a canary build based on latency in the queue and stuck messages and stuff.
Yep. Makes sense.
You can actually, depends on the traffic of the service. If it doesn't get an HTTP and gRPC and you want to alert on something else and fail the deployment, even on custom metrics you built into the app and instrumented yourself, you can do that. The basic that comes with Flagger and supports the service mesh you have is latency and success rate.
Okay.
And you can say the threshold for this canary is 99% success.
Well, that's a pretty high, but let's say that I want to shoot for a high reliability. Yeah.
So if the new canary deployment achieves 98%, you can just fail the canary and roll back the traffic to the primary. The thing with this is that unlike normal Kubernetes deployment, you get only a chunk of your traffic failing. So if you are promoting 5% to the canary instance, only 5% of your traffic will get affected
which means that, again, not necessarily fully failed, right?
Yeah.
It is in essence a blast radius management mechanism. That's what it is.
Yeah.
One sort of like curious question, I previously mentioned that we extended the functionality of what Flagger is doing in different stages with our own service, Puerta. How important it is Flagger, let's say for those of our viewers who'd like to get started on progressive deployment, is it good enough without any extensions, or do you really need some sort of bare minimum of custom hooks in order to get started? What do you think here?
So we wanted to extend Flagger in order to support our philosophy and the way we believe the gates should behave, and like time constraint for deployments and release train and stuff. The thing with Flagger is that it's really, really simple, unlike Spinnaker and huge solutions that became before Kubernetes.
It is a lightweight and very simple operator, very true.
It's very lightweight, and in order to extend it, you just need to support the Flagger webhooks. So Flagger gives you a set of webhooks and tells you exactly when it will shoot them. So you have pre-rollout, pre-release,
Yeah,
and
different stages.
Yeah, you have all the stages, and you can you can configure a webhook that will shoot to an endpoint. You configure even launching your E2E pipeline via CircleCI and stuff, and you get that flexibility via webhooks, and
Yep.
you don't need to extend Flagger in like forking it and stuff.
Absolutely no. Okay, yes, we definitely use the out of the box one.
Yeah.
Okay, you know what? You mentioned service mesh and its role. Let's talk about the service mesh. So for me, this is the first time I'm using service mesh in a production environment, not for OR. For me, really, in a nutshell, service mesh is a web of proxies, right, attached to each and every pod as a sidecar, I think, right?
Yeah.
So that every outbound communication from the pod goes through these proxies. In essence, every inbound also has to come from some other proxy.
Yeah.
There's just no other way to talk to different pods. And all of them have a common control plane through which we can do many things, not necessarily related to continuous deployment, right? Or
Exactly.
mentioned the monitoring of various metrics. Definitely the security policy, who can talk to whom
Yeah.
and do what. Particularly, though, in the continuous deployment world. What are the special capabilities that service mesh gives you as opposed to doing the same continuous deployment with the same Flagger, albeit only with my typical ingress controller? What is the functional gap that we're gaining here?
So the SMI traffic split object is updated by the Flagger mechanism and can actually write and change the weights.
Yep.
And the service mesh that receives the traffic split and applies it to the traffic can actually see the entire traffic because it sits as a
All of it
sidecar.
comes through proxies. Yep,
Yeah.
absolutely.
The entire Kubernetes mesh is actually talking to each other via the proxies. So you get additional stuff like instrumentation and TLS and everything. Everything is secure, and you never use HTTP inside your mesh, but it's transparent.
Yeah.
And
These are the benefits still regardless of
yeah,
CD.
yeah, exactly. But the thing is that if, as an application, I call you via the proxy,
Yes,
and
sir.
it sees the entire traffic, it can say, I got a config that says I need to send 5%,
10% in this case, but
10%, yeah, and 10% instead to you to a new instance.
Yep.
And this happens transparently on the proxy without you ever configuring an application and ever knowing about where to send traffic. So your application speaks.
I'm just
normally,
calling service
yeah,
A calls service B, and somehow this traffic gets split between B and the upcoming canary.
Yeah.
But wait, in theory, or actually in practice, many people unfortunately do not have service meshes deployed. So for them, for instance, when they consider doing progressive deployment with Flagger, probably the more appropriate diagram would be something like this, where the mechanism through which traffic splits is being enforced is an ingress controller.
Yeah.
There are a lot of popular ingress controllers, and quite frankly, most of them, at least the most popular ones, are indeed supported by Flagger. So what's the big difference? Is it exactly the same benefit you get for your canaries, or is there still a gap and a reason why you should consider service mesh in order to build a real progressive
Yeah.
deployment?
So you don't really need a service mesh if you don't have to, or it's a big adventure and takes a lot of convincing inside the organization. But you can start with your ingress controller. Every Kubernetes has
Absolutely.
some ingress controller, and Flagger supports a lot of them. And the thing with ingress is that you will benefit Canary only for the first hop.
Right, the
Yeah.
top sort of like tier of my services, because these are the ones receiving traffic directly from the ingress controller, and there, of course, I'll be able to do the split. What will happen to the rest of my services, right? The deployments, Kubernetes will still create pods. Who will get the traffic? For instance, just to explain, so here we have in the schematics, the Nginx ingress calls this either service primary and service canary. Let's imagine that this service calls another B service.
Yeah.
Unfortunately, there we do not control a traffic split because in the absence of service mesh, it just goes over the overlay network. So how will, let's say I deploy out a new pods, what will happen? Just a round robin, random?
Yeah, so you wouldn't use the canary CRD in internal services because you won't benefit from the traffic split.
Understood.
And the thing is that most architectures is using some kind of API gateway that routes all the traffic to internal services. So only this service, the API gateway, will benefit from canarying,
right?
Because the traffic split won't work internally. So we at StackPulse believe that each service should have a canary rollout. So
absolutely.
Yeah, so we have lots of microservices talking to each other, and we'd like each one of them to have a canary. And by using service mesh, we are getting the traffic split.
Exactly. No matter how deep the service relies in our architecture. So again, to sum this point up, if you don't use service mesh, and again, we are fully aware that this is a technology that is more rarely seen in production, in order to do a real progressive deployment, it is quite easy to benefit from gaining a canary on your top tier, sort of like out-facing services. When it comes deeper, either API gateway or, unfortunately, doing real canary just for your top tiers is the solution you're left with.
It's a good solution, man, because most people don't have at all. But the thing is with API gateways is that if they accept all your traffic, and you fail there, then nothing will work. And it's a good thing to do with gradual rollout, even for an API gateway, and it's a good thing to do. Anyway.
You know what, you mentioned gradual rollout. Let's talk about maybe one of the more controversial subjects we have here. So guys, by now you know pretty much about how we work. You know that we do a lot of automated gatings. We do them inside our continuous integration pipeline. We do them at various stages of our continuous delivery pipeline. And yet we are still huge believers in dark launching or flags flipping, which means in essence that every time a significant portion of our business logic changes, on the engineering level, people surround it by this conditional block where they reach out to an external system. There are a number of commercial and open source solutions. We chose Flipt, as you can see, and sort of like that surrounded block provides the session info, the user, the account, geography, IP, time of day, God knows what, a lot of parameters, and gets a decision made by an external system whether the functionality should be enabled or not. Now, why do we need this? We go through so much trouble with automated gating, end-to-end testing, this progressive canary where we gradually flip traffic. Why do we need this additional logical level of control? Isn't it excessive in your opinion?
So the thing about canarying is that it does that for the entire instance, okay?
The service that we are deploying, of course.
We are deploying a binary, okay? We are deploying
or a configuration change, it's the same.
Or a configuration change, exactly. So this thing affects the entire blob that released to production.
Absolutely. The service is the service, right? However amount of endpoints it serves, all of them get affected big time.
And this is a very expensive operation.
We sure hope to make it less expensive with granular updates, but still it is.
But yeah, it takes time to run a canary, and we need a lot of confidence in our gating service, and we do that with end-to-end testing and
hundreds of scenarios that within time will turn into probably thousands. So and still,
and we test in canary. We test the entire service is not breaking its contract and everything, and if it does,
set of flows. Yes.
So this is one set of gates.
Yes, sir.
With new features and new releases of new pages and
Whatever functionality, really
new
whatever.
behaviors, you want to control not at the instance level but at the code level. You want to hide a chunk of code or a
Right.
page or a single thing inside the same binary. So with feature flags, you can either use A/B testing to measure your user's behavior and
True, that's a
say-
separate, the A/B.
and-
Yeah,
and we use feature flagging in that context
right.
for like you said before, blast radius reduction,
Yes, sir.
and we can release new features often and actually turn them off if something goes wrong instead of rolling back the entire blob.
Yep, the entire
Which-
service. Yep.
Yeah, which is, like I said, expensive.
And risky, by the way. Not only expensive, but it also is risky in terms of.
Yeah. It's expensive to roll back. We usually just turn off a flag, fix the code, and roll out a new
So
version.
always forward rolling
Yeah,
motion.
we tend to do it forward unless this fix will take more time than rolling out,
That makes
rolling
sense.
back, and it's a set of trade-offs. We prefer to just turn off that chunk of code and move forward, fix it, release a new version, and this mitigates the entire
Risk,
bug
sort of like it's a risk thing. Yeah.
that we have in production.
One important piece to add before we move ahead for flag slipping is that it is very important to have a process that within time systematically identifies flags that were already turned on for general availability,
Yeah.
goes back to the code and removes these conditional blocks. Because otherwise, if you don't do it, and we've seen environments where unfortunately it doesn't happen, your code will turn into, it's not even spaghetti, it's some other type of pasta where every new addition is sort of like surrounded by blocks, etc. Right? It is very important to understand that if you go this route, you need to have a discipline to make it temporary. Temporary is not from today to tomorrow. Sometimes it may take us a month to gain confidence in a certain change, or if we do A/B testing, then you know what, one of them will end up being not the chosen option, but still. So guys, I sure hope that it is useful, our discussion here. To sum up some of the points, first of all, application metrics that are so important for performing progressive deployments could be gained automatically by using service mesh, latency, success rate, etc. But if you do not have service mesh, you can still do the same metrics applicatively by yourself. And this is like 50% of the benefit we gain by using service mesh. The other 50% is the fact that we can now do the traffic shift not only on the top tier, right, in the entry level, but actually inside even very deep in sort of like second, third, fourth, fifth, no matter how deep tier of our services. And that piece is the benefit that you will get easily only with service mesh. Trying to close that gap with an API gateway is possible, but it's not easy. We did custom gates from our progressive rollout, but it is not mandatory. We used it to express our own culture. Flag slipping, as you've seen, for us, again, it is a very main thing. We couldn't imagine our life without it. And remember that piece we started with, the fact that our continuous deployment pipeline is separated from the CI by a reconciliation loop, which is declarative. This is the state we desire in our production, and now it's a goal of a certain continuous component to maintain that state, no matter what changes it, right? So it could be either the desired changes, and we now need to fix the production, or for some reason the production state changes, and we need to align it back to the desired.
And also, like I said before, so we believe in infrastructure as code and going through the same procedures as developers. And
Absolutely.
by using a reconciliation loop that enforces people to go through Git, because if they change manually and 5 minutes after Flux runs, it runs over the changes.
Absolutely. That's a reconciliation loop mean.
Yeah, and it enforces devs and SREs to go through the normal processes as developers, going through PRs, people audit it. We get all the benefits of Git and code inside infrastructure, deployments, and everything is audited and viewable, reviewable, and
Sounds great.
yeah, sounds.
Guys, we are Or and Leonid, and we sure as hell hope that you enjoyed this presentation. We're available for any questions. Reach out to us. Thank you.
Thank you very much.